Overfitting is a general problem when we work with neural networks. What are two techniques that we can use to avoid this in autoencoders? The autoencoder that we saw previously had just one hidden layer, the codings layer. Now, what if we wanted to make the autoencoder more powerful? This is possible by adding more layers to our neural network. A stacked autoencoder is one which has multiple hidden layers like you see on screen. Even in a stack autoencoder, the structure of the autoencoder is typically symmetric around the hidden layer. So we have the smallest layer, the codings layer at the center, and then we have layers of increasing size along the sides. Remember that the input layer and the output layer should have the same number of neurons or the same dimensionality. Adding more layers to the autoencoder neural network allows it to learn more complex patterns in the underlying data. However, you should be careful not to make the autoencoder too powerful. If the autoencoder were able to completely learn the input training data set, then it's essentially useless. You have overfitted to the training data. This such an autoencoder has not extracted the latent factors or the factors which drive your data. It simply learned everything, kind of memorize the training data set. Just like we studied with other deep neural networks, overfitting is a serious concern with stacked autoencoders. So, when you construct the architecture of your autoencoder, make sure that you don't overdo on the stacked layers. There are several solutions specially suited for autoencoders to mitigate this problem of overfitting. One solution is to tie the weights of symmetric hidden layers so that they are exactly the same. Here, notice that hidden layer 1 and hidden layer 3 are symmetric. You can force them to have the same weights and biases. This is one other way of constraining the network so that your autoencoder doesn't overfit the training data. You can also change the way in which your autoencoder is trained by training individual hidden layers independently. So you would first train the hidden layer 1, then 2 and 3, and then get them all to work together. Autoencoders are used as a pre training preparatory step to supervised learning algorithms which work on very complex data or on very complex problems. You know that supervised machine learning tries to figure out the function f which links the input features with the output. If the feature vectors are very, very complex, it's very hard to see what exactly is the data that we should pay attention to. It's very hard to see what data is important. And this is where autoencoders come in. You'll use autoencoders in an unsupervised pre training step, which is done before you feed the data into your machine learning model for classification, regression, or any other supervised training algorithm. You'll use the autoencoders to find hidden patterns in the complicated feature data. Once you've figured out the latent factors, you can simply use the lower dimensionality latent factors to feed into your supervised learning model. We'd spoken early on in this class that neural networks were a kind of representation learning systems. Neural networks figure out by themselves what data is important, what features are important. Unsupervised pre training using autoencoders make the supervised learning easier and less reliant on human expertise in feature engineering. Unsupervised pre training can be thought of as the feature selection algorithm for your supervised models. Autoencoders are generally symmetric neural networks. The number of neurons in the input layer is equal to the number of neurons in the output layer. The number of neurons in the second layer will be equal to the number of neurons in the second to last layer, and so on. One way to mitigate overfitting in an autoencoder neural network is to tie the weights of these symmetric layers. So, tie the weights of the second and the second to last layer to force them to be the same. Another solution is to train each layer of the autoencoder separately and independently.